All right, it's time for some more verifying trig identities. This one is going to be the 6 problems under the heading Verifying Trig Identities 3. So let's just jump right on in and see what these held for us. All right, problem number 1. I am going to take the left side, turn it into the right side, and I am going to actually multiply out 1 plus tangent of x times 1, minus tangent of x. Write the right thing down. Let's see, FOIL or distribute, however you learn to multiply. So 1 minus tangent of x minus tangent of x plus tangent x, tangent squared x. Let me say it in the right order. So let's see. If I'm looking, remember, I always want to look to this right side to see what I'm trying to turn it into. So I can see that I have negative 2 tangent of x, but somehow I need to create a secant squared. So I'm thinking if I take 1 plus tangent squared x, so 1 plus tangent squared x minus 2 tangent of x. This term is one of my Pythagorean identities that I can replace with secant squared x minus 2 tangent of x, which is exactly what I was looking for on the right side. All right, so that's problem number 1. Let me slide it over to number 2. Number 2, I'm going to go ahead and multiply out this numerator. So I know because they're conjugates of each other that I only need to pay attention to the first and the last terms, because the 2 middle terms will cancel. If you need to see it, I'll write it out. So there's 1 minus cosine of x plus cosine of x. Those are the 2 that are going to cancel. And then minus cosine squared x all over, I don't know why I'm trying to put an s in front of cosine, cosine squared x. So those are gone. 1 minus cosine squared x over cosine squared x. That is a horrible, wow, that wasn't even close to an x. All right, 1 minus cosine squared of x can be replaced with sine squared x over cosine squared x. And if you have a sine squared x over cosine squared x, that is really the same thing as a tangent squared x, which is the right side of the problem. So problem number 2 is all set and done. All right, number 3. Ooh, that is not exactly the prettiest problem in the world, but it actually simplifies relatively nicely. You have 2 Pythagorean identities here. 1 plus tangent squared of x is secant squared x. And the denominator, sine squared x plus cosine squared x, is my favorite Pythagorean identity, which is just 1. So that is secant squared x divided by 1, which is really just secant squared x. So number 3, while it looks pretty nasty, is actually one of the easier problems if you know your Pythagorean identities. Make sure you do know them and can reference them. Problem number 4. Let's see what we got here. I am going to try to turn the left side into the right side. So I'm going to get a common denominator here. So 1 over tangent of x plus tangent squared x over tangent of x. In order to add fractions, you have to have a common denominator. And if you don't, you have to make one. So make sure you know how to do that. So let's see, that numerator 1 plus tangent squared x is secant squared x over tangent of x. Let's see what this can kind of simplify into here. So secant squared x is really 1 over cosine squared x, and I'm dividing that by tangent of x, which can be rewritten as sine x over cosine of x. So 1 over cosine squared x times cosine x over sine x. So this cosine will take out one of those 2. So let me go ahead and drop those out. So now I have 1 over cosine, which is really secant of x, times 1 over sine, which is cosecant of x, which if I zoom in is exactly what I was looking for on the right side. So always keep in mind what your end goal is so that you don't kind of veer off into some other you know, some steps you have to do, but sometimes I've fallen down, like I get going in one direction. I realize, wait a minute, I wasn't supposed to be doing that because that's not going to help me get to whatever the other side of the problem is. So just be careful with those. All right, number 5 here. Oofed. All right, so somehow I need to turn all of these tangents into some secants, or turn all the secants into some tangents. Well, let's do a little, I guess, factoring. I'll work on the left side to turn it into the right side. So on the left side, if I factor out a tangent squared x, that would leave me tangent squared x plus 1. I need to convert to secants. So let's see. Tangent squared x is really 1. Nope, I lied. It is secant squared x minus 1. And then tangent squared x plus 1 can be rewritten as secant squared x. This actually is working pretty easily. And I'm going to distribute back in. So I get secant to the 4th x minus secant squared x, which is the other side of the equation. All right. And one more, problem number 6 here. Let's see what we've got here. So I'm going to turn the right side into the left side. So 1 minus sine squared theta. I've been working with the Pythagorean theorems, Pythagorean identities long enough that I recognize this one as cosine squared x. And if I take cosine squared x times cosine of x, I am absolutely going to get cosine cubed x, which is what I wanted it to be. All right, so all 6 of those problems are said and done for verifying trig identities part 3. I keep saying it, but please make sure you have a chance. If you have questions, ask them so that you know how to do these problems. And if you have a different method of solving one of them that you want to check with me, feel free to tell me about it.